Итак, сейчас у меня будет тур на атомную электростанцию в Австрию.
When the former Chancellor Klaus, he was a conservative party chancellor, decided to build 3 nuclear power plants in Austria to ensure energy for Austria. And building period starts 1972 already, so only 3 years of planning, and then 1972 they started to build this reactor. Zwentendorf here was the first one to be built. From 1972 to 1976, so 4 years of building time in total, and then from 76 to 78 there was a trial period. So it tested everything, the whole reactor, every single lamp was tested, and then in 78 they brought the fuel here, so the fuel rods have been brought into dry storage, and since that the whole nuclear power plant was ready to go into operation. From that moment, it would have only taken about 2 weeks to bring it into operation. The thing was that back in the time there were a lot of protests against nuclear power, and that forced the former Chancellor Kreisky, which was then from the Labour Party, forced him to do a referendum about bringing it into operation or not. The referendum was on 5th of November 78, and as you guessed, the outcome was negative, but it was very close. It was about 30,000 votes, so 50.47% against nuclear power in Austria. That's why it never has been into operation, and the other 2 nuclear power plants which have been planned were never built. From that time, the owners, the former GKT, which was Gemeinschaftskernkraftwerk Turbine, was the former owner of this nuclear power plant. They decided to kind of make a conservation period, because they thought probably the Austrians will be smarter in the future and will flip the outcome of the referendum. So there was a second referendum planned. But in the end, this conservation period was about 7.5 years. So 7.5 years, everything was wrapped up in plastic, so it will not corrode. And yeah, after 7.5 years, it was about 85, 86, and after Chernobyl has happened, it was completely clear that nuclear power will never have a majority in Austria. From that time, they tried to sell some parts to bring in a little bit of money, but it doesn't work very well. Therefore, we still have a lot of the interior there. Only some parts are missing. So we have sold one of the turbines, we've sold the generator, but the most important parts are still there. And you'll see them in a short amount of time. And then, also before we go in, let's just show you a picture of our site. So you can see what kind of buildings we do have here. So we have here the road leading to the area of the power plant, and the whole area where no trees is all part of the power plant site. There's the reactor building in the middle, so it's the higher one, 64 meters in height, and then there is the machinery hall, the turbine hall, right next to it. Here in the front we do have the building for offices, laboratories and switching gear. So all the right side is switching gear, all the left is office and laboratories. There is also the control room we will visit as last slot. Then we do have this smaller building, We will pass it while going back because we will enter the power plant here. This is the building for the emergency diesel generators. We have had 4 pieces with each 3 megawatts of power. So we have redundancy. 2 were necessary to cool the reactor in an emergency situation. So we had 4, which was redundancy. Then we have this building, which was for the local fire department, just for the power plant side. Of course, it's not active anymore. And then we have the workshops, where we have the hot and the cold workshop. The hot workshop was mainly decontaminizing stuff before you can handle them in the cold workshop. The hot workshop is decontamination, cold workshop just work on the materials, normal mechanical work. And then we have the chimney, which is the final part of our huge kind of air condition, because the whole area, which is called control area, where possibly nuclear particles can be in the air, is kind of rather than a lower pressure, so that if you open a door, the air is coming inside and nothing of the air is going outside. And you don't bring any nuclear particles uncontrolled out in the environment. So the air from inside the building is going through filters and then some delay areas and then up through the chimney on 110 meters. Yeah, and finally, we're producing energy with our photovoltaics with 460 kilowatts of peak power. And one thing I forgot, 2 high voltage lines. We have 2 high voltage lines. There is the higher and the bigger one, 220 kilovolts to feed the produced power to the grid. And then there is the smaller one, 110 kilovolts, to get power from the grid during maintenance. Of course, you know, a nuclear power plant which is not in operation consumes a lot of power, therefore we have the second high voltage line. Yeah, we do also on Fridays in the morning. Yeah, there are tours for schools. We do have universities very well. We do have photo workshops.
В Германии находились 4 идентичные атомные станции тип реактора СВР-69. Все 4 идентичные атомные станции в Германии уже закрыты.
Is there anyone that haven't been to Chernobyl yet?
Yeah.
No, you're lying.
Ja sam nebyla, Wir sind von Bagierstelle.
There's a secret button behind you, I think. Podle mě tam něco mačká v rukou, ne? Určitě nějakým dálkovým ovládáním.
Which was possibly, which was possible safely. Everything was safe. We have the cap here, so this is the lid of the reactor pressure vessel. You can go there. You can look under. About 60 tons in weight. important, interesting is the core itself. In the core, guess what? We have uranium 235, and it's filled into these parts, which is the fuel we have in this nuclear power plant. So there are these small tubes, fuel rods, filled with pellets of uranium, and we're stacked together in this size, 484 of these filling one reactor. The grabber, which can go down, grab one of the cells, bringing it to the storage pond and leaving it there to cool down. But not during operation, only during. They're very strict about going close to the pond, because if you drum something small storage something, you have to shut down until you get it out.
А вот это как душевая кабина. Сюда ставились стержни. Из этих шлангов они поливались, мылись. Вот эта дверь закрывалась полностью. Вот по рельсам. Это как душевая кабина, когда менялись урановые стержни здесь. Их вынимали, ставили на мойку. Вот, так что это такая мойка урановых стержней. Wow.
Lager für neue Brennelemente.
Склад для новых урановых стержней, где их хранили и подготавливали для будущего использования. То есть эти вот ниши — это для урановых стержней.
Jenom dokola. Jsme se vrátili.
Tady nejideální zavřít.
Toto? Pálí si tam nejprve.
Ne, o to nejde, mě to nepřijmí.
když koukáš pod nohy, víš, tak prakticky špatně vidíš, kde co je. Kousek za mostem první vodíkovou chodničku.
Vlastně já myslím, to je taková slepá ulica, ten vodík, ale vnímat, že není.
Mně se tohle stojí za mnohem lepší, než tady baterie. Baterie samotné sami do sobě schopné. Bude to tam napsat
Тесла, 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 настоящая Тесла. Сейчас я нахожусь в комнате, где пар из турбин давался сюда и охлаждался. Если бы станция работала, меня бы здесь заживо сварило, я думаю. Просто в пароварке. В этих местах должны были содержаться бочки с радиоактивными отходами, но мало радиоактивными отходами. То есть здесь могли с этим работать люди еще. Вот радиоактивная пыль со всяких фильтров подавалась в эти бочки, которые тут стояли. И вот они так вывозились, и можно было их транспортировать. А вот эта бочка, кстати.
Actually, everything was here. Really everything. They already had all of the walls. They already had all of the. Be careful not to fall in. Please. Below the core itself. Therefore, the radiation in this room would be very high. Still, two engineers have to come here per day in the running power plant to check everything, because this room is the most important room for reactor safety. Additionally, to the control room drives, you have the you see the metal rails there, 6 pieces all around the room. That was the mount for the cooling pumps. They're sold already, and since you have to seal it, there are rubber gaskets, and to check if the gaskets are sealed or not, if they have a leakage. Engineers would come here, take a look inside, and you see all of the pipes will end there. And if you have water dropping
tu, a że
out
gdzie
of
tam
one of
kapka
them,
woda,
you know,
takže
the
vieš, že tam
gasket
je
has a leakage,
tiesnenie
but
partikel.
then you have to change it. So therefore you the reason because you need that is firstly with the electrical motor it takes about 2 minutes to bring it in totally, which is very long time for nuclear. And the second thing is with the they did during the conservation period, because when they realized they cannot switch it on at the moment, they wanted to kind of conserve it for a later date. So they have to make sure there is no corrosion and stuff. Therefore, they wrapped everything up in plastic like this, so that the equipment can hold all the time with no corrosion. Yeah, in the end, since we never switched it on, some of the parts are still wrapped up in plastic.
Ne, to bylo za provozu, že by jsem stejně musel jít na lidi. Přijde a vidím, že by to
Důležitější část.
Я был вот там, а сейчас мы в турбинной комнате.
Well, we have heard about steam production from, and here it is. We're now in the turbine hall. I will explain how the steam is turned into electrical power. We have the reactor. Steam is coming out 70 bars, 286 degrees. Then we have a high pressure turbine. Steam is going in the high pressure turbine. After the high pressure turbine, we have about 10 bars of pressure. Then we have a water separator and a steam preheater to bring a little bit more energy to the steam, because steam is losing a lot of energy on the first high pressure turbine. High pressure turbine brings 40% of the overall power of the turbine set. And after the preheater, the steam is going on 3 lower pressure turbines, which are working from 10 bars to 0.06 bars. In the end here we have 0.6 bars with approximately 30 to 35 degrees. And this temperature, pressure levels, we still have steam. Therefore we need the condensers to bring back the steam to water, so to condense the steam, and after that the water is brought back to the reactor. Then you have some preheaters, you have filters, and then you have the pump which is bringing the water back into the reactor. This is in total the whole cycle. We do have 4 turbines in total, but only 1 turbine set, so they are all connected with 1 shaft, and you cannot disconnect them. So if 1 turbine is rotating, all of them are rotating, and they all connect the turbines with the generator. If you look into the room, we have the high pressure turbine there. You will see it later. Then we have the first lower pressure turbine in the blue housing. This is how it looks during operation. Then we have it, the second one is open. This is how it looks like in maintenance, so you can work on the turbine. And the third one is sold because German power plant bought this one. And yeah, it's gone. And the generator as well is sold. But you have a photo here, how it looks like in the final state. Yeah, we will go on the platform now to see the turbine a little bit closer. But if you're on the platform, be careful not to drop anything, because everything you drop there is in the condenser, and won't be possible to get it. Okay, so close your pockets and be careful not to drop anything. two-sided. So steam is coming from the middle, going to the center, and the steam is going then to the outside. The reason for that we have two-sided turbines is, first of all, the weight is more balanced, and second thing is, if you push the steam only in one direction, there is a force pushing in one direction. If you have the steam going into both directions, the forces are equaling themselves, therefore it's much easier to handle that. The rotational speed of the turbine is about 3000 RPM, which is 50 per second, and as most of you know, we have 50 Hertz in our Central European grid, therefore 3000 RPM. With 3000 RPM, there are forces pulling on these shuttles with about 500 tons. And if there is some vibration, or if there is water drops on the turbine, this will harm the turbines, and since they're very expensive and very hard to make, you really look after these turbines. There was a German, well, happened a lot of times, but there is a German coal-fired power plant which had a turbine similar to that, which exploded because of failure in the construction. And if some of these particles, the shrapnels, with 1 ton of weight, are penetrating the walls and are kind of all around the place within 1 kilometer of diameter. So there's a really huge force behind that. And this is the reason why you have the reactor building here. This is the reason why the turbines are located 90 degrees to the reactor, because if the turbine blades are going out, leaving the building, they are not in the reactor but somewhere else. This is the control room. Just a few words to tell about. As you see, it's mostly like back in the 70s. There are some parts which are not original. You wouldn't guess, but the clock on the wall, which points 5 to 12, is not original. So originally there was a digital clock, but there was a movie set in here, and the regisseur wanted to have an analog one which was pointing 5 to 12. And after the movie set, we couldn't find the original one, therefore we still have that one here.
Which movie was it?
Some low budget, never seen it. Also the computer we have here is not original, because as you see, it's from the 90s. But the control room and the whole power plant was built in the 70s. We have had the first computer in private, let's say private use back in the 70s, which was that one. So output and input panel here, and the computer itself was filling the whole next room. Parts of that are now in the technical museum, and yeah, this remained here. The books you see on the desk, they are also original. You see the date from 90s and 70s and 80s and what's on. So you see also the original shift books here. The reason why you see the shift books are filled out until 1992 is we had the fuel here until 92, because as you guess, it's not very easy to sell already not used but unwrapped nuclear fuel in Europe.
So where did you sell it at the end?
At the end, we sold it back to the manufacturer.
It was?
Don't know the name, but it was from Germany.
Požádal bych ten stav za slečnama, aby odešel.